Thank you, Pelham. It's a great thing, but also kind of a double-edged sword to have a chairman who stands in front of audiences like this and says, we're almost there, because it kind of puts the pressure on a little bit. But there's nothing wrong with a stick on your backside, is there? I have to do a little bit of housekeeping first to make a couple of fire safety announcements. The first is that if you do actually discover a fire, then break one of the glass fire alarms, or the nearest phone, go to the nearest phone you can find and dial 777 and someone will assist you. If you hear an alarm, it is a fire. There are no tests today, or at least it's possibly a fire. There are no tests today. Or you'll see that all the fire exits are labelled by these green signs. If you go into the space outside, there's an exit at the front where you came in, and there's another exit at the back. And if you could please congregate by the dolphin fountain that's outside. And please don't re-enter the building until someone says it's safe to do so. All right, that being done, I am, for those of you who don't know me, my name's Chris Bunce. My background is leukemia and lymphoma research. And just over 2 years ago, I had the honor of becoming the research director for this organization. Having been a researcher for several decades before that, I have benefited, and my colleagues have benefited from the work that people, the supporters like yourselves, have done. And I now have a very rarefied viewpoint of having seen that effort from both sides of the fence, and I am just simply in awe. The stuff that this charity does is just amazing. Okay. So I know you won't be able to see this, but this is the timeline of cancer. And it starts back here in the 1900s, and at the end it says 2015. And I'm going to try and take us on a little walk across this journey. To make it slightly more visible, I've split the timeline into two. So we have the 1900s at the end, and we have 1960, a significant date for us all at the end. But in actual fact, the most dramatic quote that I've found in making this talk up is that this quote, and I'll read it for you because you won't all be able to read it. It says, "It will, in short, become possible to introduce into the economy a molecular mechanism which, like a very cunningly contrived torpedo, shall find its way to some particular group of living elements and cause an explosion among them, leaving the rest untouched." And this is a quote from 1881 by Thomas Huxley. Thomas Huxley was known as Darwin's bulldog. So Darwin had the ideas, and Huxley went around bullying people to start considering them. And they were obviously thinking about evolution and how some organisms can be selected for death whilst others are selected for survival. And in actual fact, that's what we're trying to do here. We're trying to select cancer cells, exterminate them, and not harm the other cells in the body. And this was the first demonstration that I could find of a concept known as the magic bullet. The term magic bullets is largely ascribed to a German chemist called Paul Ehrlich, who was working in the early 1900s. And he was one of the first people to consider that you could actually use chemicals that would be selectively toxic to something that you wanted to kill and not toxic to something you wanted to keep alive. And the term magic bullets came around. He actually wasn't working on cancer. He was working on something at the time which was a major clinical problem. He worked on syphilis. The concept, however, was a difficult one to swallow. And even in 1940, the concept of magic bullets still had very much a science fiction air about it. So much so that Warner Brothers made this film starring Edward G. Robinson telling the story of Paul Ehrlich. And you can see from the graphics that it was very science fiction-esque. Sort of a test tube in the shape of a bullet. Kind of a good joke, I suppose. And that's 1940. But in actual fact, the pioneers of chemotherapy were actually in the cancer field anyway. The pioneers of chemotherapy actually worked in blood cancers. And here I've highlighted between 1940 and 1945, where people started to try and use chemicals to work on lymphomas. Now, these chemicals were derived from and not very much modified to actual chemical warfare weapons. So this is mustard gas, essentially, in a form that you can inject. Now, that's quite alarming to think that something that was used in warfare to kill people is now actually being put into patients to try and kill their cancer. But in actual fact, many of the ways that we still treat cancers still reflect this origin. So a lot of people in this room have known people or have themselves been through treatments where essentially you're playing a game of poisoning and you're trying to poison the tumour whilst not poisoning the person who has that tumour too much. And what we're going to talk about today is how we're about to start to look at that and think of that as history. And that's probably one of the exciting messages that I hope you will take home today. The first sort of biological intervention, an understanding of biological molecules that were not poisons, that could actually interrupt with a cancer, came shortly after that, before 1950. And these were the first chemotherapeutic trials done in children with leukemia. And this treatment, this antifolate treatment, was published on June the 3rd way back in, I can't remember the exact date, 1948 I think it is. It was very, very exciting, but the authors were also very, very cautious to point out that what they had seen is some effect on the disease. So the disease had a partial remission. The level of disease dropped away for a little while, but it always came back. And they were very, very, very careful in their description of their work to say that this is not a cure, but what we have seen makes us dream that there will be cures. And I think this is the point in history when chemotherapy really, in reality, started to take off in blood cancers. And just on the end there, why I said 1960 is an important date for everybody in this room, that is when this magnificent charity was first formed. Rather less impressively, it was also the year I was born. So what did it actually look like in the 1960s when this charity first formed? This is an interesting article. It's called The History of Cancer Chemotherapy. It's actually written in a language that's quite accessible. So if anybody wants to know where to find it, I can point you in the direction of it. And it sort of walks you through, I have to say, a very American viewpoint on how the war against cancer using chemicals has been waged. But it's a useful document, and there's some really interesting quotes within the document. In the 1960s, medical oncology did not exist as a clinical speciality. Talk of curing cancer with drugs was not considered compatible with sanity. And in the article, there's some anecdotes that are illustrative of this. This is not just said for effect. There are historical events. So people had treated people with cancer, seen a good effect, and told they were mad and asked to leave their job. And the improvement in the cancer that the patient has seen was ascribed to a spontaneous remission. Such was the difficulty to actually establish this principle, not very long ago and when this charity started. So the other quote that I like in here particularly, it says, "It took plain old courage to be a chemotherapist in the 1960s, and certainly the courage of the conviction that cancer would eventually succumb to drugs." And we are indebted to those people who had that vision and had that courage. And the modern day equivalent of those people who had that vision and had that courage are the people that we now support. So we're now into the second half of the timeline, and you'll notice there's drugs that are starting to crop up in the background. Drugs are becoming available. I've left a circle at the start of it to remind us where we were at. And one of the exciting things that I would like the people here to relish and take home with them is that, yes, we are an organization that wants to improve the life and the survival and the quality of life for blood cancer patients, and that we support research which is centered around blood cancer. But many of the advances that have come in the cancer arena have actually come from blood cancer research. So many of the new modalities of therapy that we're going to talk about today, many of the discoveries that we're on the cusp of making that we're going to talk today, will have application in other cancers, and even beyond cancer in other diseases. So the analogy I like to use in my mind is that cancer research is a beautiful bright comet flying across the sky. And the really important bit, that's the brightest, hottest bit right at the front, is blood cancer research. So I'll try and illustrate why I argue that with the next couple of slides. So very shortly after the charity begun, trials around the world, including in the UK, were starting to report not just remissions in children with leukemia, but actually cures in children with leukemia. And also, around this time, Hodgkin's disease, former lymphoma, which was a major, major problem, had an almost overnight improvement in success rates. Quite impressive improvement in success rates. And it's important that we recognize that progress that started shortly after the charity started is actually dependent on the courage and hard work of individuals who were working many years before the charity was formed. If we now fast forward, not very far, we actually come across this drug, imatinib, Gleevec, which is the most talked about targeted drug therapy. This is a drug that recognizes the mutation in a cancer and what drives that cancer, and the drug is targeted specifically against that mutation. And only the cancer cells have that mutation. So the drug only has activity in the cancer cells. And when this came about, it made the front cover of Time. This is a new ammunition in the war against cancer. These are the bullets. So this is Huxley's and Ehrlich's dream recognized. And recognized based on hard work and biological understanding and research. However, if we remind ourselves again how long that actually took to come about, doesn't matter if you can't read the points in this timeline, the original discovery of the mutation, something we'll hear more about later in the day, was actually discovered back in 1960, and it's not then until 2000 that the drug actually becomes licensed in the States and here for use. And there are, I'm sure, well, I wouldn't be surprised, or no, I know I'm sure, there are people in the room who are taking these drugs and just getting on with their life, living a normal lifespan. It's quite remarkable. Now, we can take, as a charity, some considerable pride in this particular story. This is John Goldman, who sadly died over Christmas last year. But John Goldman, throughout his career, was very, very closely associated with this charity. And his last role with the charity was that he actually chaired the steering committee for our Trials Acceleration Program. John Goldman is an example of a clinician who cares so much about patients that actually wants to understand and learn about the biology. So John Goldman sort of left the wards and went into a research laboratory and learnt about cell biology, learnt about molecular biology, and wanted to understand the origins of this disease. The disease was associated with a chromosomal translocation, which we'll hear more about later in the day, but it seemed to arise in some individuals that didn't have that chromosome translocation. And therefore, we weren't quite sure that that was what was driving the disease. But John and colleagues actually showed that in those cells that didn't look quite as abnormal as the others, the same mutation was there, but it was in a smaller aberration and more difficult to see. And that actually was the dawning of the time when we thought, yes, this disease is driven by that. And then John, throughout his career, really promoted the fact that we need to target this mutation. And he united the international community around trying to do this. And he's well recognized for having driven the need for and the reality of drugs that target chronic myeloid leukemia. And the training that he needed and the research that he needed to do to get to that point, our charity funded. So, although imatinib, Gleevec, same drug, different names, depends which side of the ocean you buy it on, is the most talked about targeted therapy, we are not a one-trick pony. There is another one out there, and it's in a disease called acute promyelocytic leukemia. And in the reviews that refer to this story, it's often defined as acute promyelocytic leukemia from highly fatal to highly curable. And the reason why it says highly fatal is that if untreated, this is perhaps the most aggressive leukemia that humans get. People die very quickly of it. But now we have treatments that can deliver pretty remarkable results in this disease. And the most recent addition to the treatment for that disease, believe it or not, is arsenic. Those of you who are football fans, that doesn't say Arsenal. And we had David Grimwade here at Impact Day last year, and he told this story in a bit more detail. But this actually came from ancient Chinese medicine. And the other component of the treatment that is targeted at this disease is something called Alltransretinoic acid, which sounds pretty fancy, but in actual fact it's vitamin A. When we eat vitamin A in our diet, our bodies convert it to Alltransretinoic acid. But if you give a high dose of the already converted form to these patients, then it targets their disease. And now there's a trial going on in the UK at the moment in this disease where patients are being randomized from vitamin A, Alltransretinoic acid and chemotherapy, to an arm that has Alltransretinoic acid and arsenic, neither of which are chemotherapy. And this is now, we're walking into an era where we're actually taking one of the most aggressive cancers that humans get and treating it biologically without the need for chemotherapy. Now, in the case of CML, people take the drug to keep their disease in check and will take it for most of their life. There's an interesting story there. They may be able to stop. But this, because the disease is so aggressive, has to be curative. So we're talking about cures, eradication of a disease, non-chemotherapeutically. But again, we have to recognize that the timeline from when we started to understand this disease to the point where we're doing trials with chemo-free results at the bottom of this list takes time. So why am I banging on about things take time? Well, we've been showing marvelous results over the time we've existed, but there are a number of things that we've discovered that are in the pipeline. So just think about what's just around the corner. So in the spirit of that blood cancers have often led the way, we've been talking about chemotherapy. That's using chemicals. Our bodies are actually quite good at fighting cancer. There's a number of things in our immune system that will help us fight cancer. And we can actually utilize that. We can take it and tweak it and improve it. And there's a form of therapy that's come about in recent years called monoclonal antibody therapy, which is actually quite remarkable. So if you can imagine imatinib is about the size of a pea, a small chemical, monoclonal antibodies are close to the size of a football. These are big things. And they're proteins. They're not chemicals, they're proteins. One could argue that proteins are chemicals, but we won't get into that debate here. And the very first one was an antibody called rituximab, and it's used now in therapy against B-cell malignancies, against lymphoma and CLL, and has been incredibly successful. And you can understand something about the economics of cancer when you realize that this drug now, the market for this drug in 2013 was, how many zeros are this? That is a lot of money. And these drugs are now with us. They'll be with us for some time, and they're great excitement. But again, the first one came out in blood cancers. And here's a timeline. You don't have to see it in detail, but I'm going to walk away. So I keep thinking I'm on those mics, but I'm not. This is rituximab. That's a hole. This is rituximab in 1997, the first one. And then these are other antibodies that have come out, and some of them are in blood cancers, and some of them are in other cancers. So again, leading the way, and you think all of these are changing patients' lives. But if we look at rituximab and focus in on that, here's another timeline. And this is the timeline of the use of rituximab in rheumatoid arthritis. So this is the point that I'm making. The work we are all doing together, the ramifications it's going to have in the future is hard to imagine, but we just cannot give up because the future looks so great. So what is next? It's hard to imagine. If we'd had asked people in the 1960s to imagine where we are now, they could not have done it. And I don't have a crystal ball. But I do know what's emerging now out of research that we and others have supported. And I'll just give a couple of examples. One is cell-based therapies. Pelham's already talked to you about cell-based therapies because that's what Anna Teller is going to do. This is the case of actually taking cells from an individual, tweaking them genetically, turning them into, I don't know, what should we say, the Mo Farah of immune cells, and say, put them back into the original and say, go get them. And to have cells that are now only really interested in finding cancer cells and doing something about it. And I like this image because it looks kind of like this big cancer cells just being attacked voraciously by these lymphocytes. I have to disappoint you, they're not really those colours. This is a pseudo-coloured image, but... And then another thing that excites me, I don't know what the other researchers think about this, is that we have genes, and Matt will talk about this, that make proteins, and then proteins have function in our cells. But proteins are quite social beasts, and they don't like to work alone. They like to make big complexes and work together. And they're actually designed to fit one another, to knit together. And this is a model of two proteins getting a bit jiggy with one another in order to perform some function. What the function is doesn't matter. But if that function was an oncogenic function and you didn't want it to happen, the thing to do would be to make a drug that gets in that gap and prevents them coming together. You know, so it's a bit like, don't argue, that kind of thing. And we have drugs that do this. This is the green thing here is a drug. The things either side of it are two proteins that would like to get together. And this is a drug that's stopping them doing it. And this is not a mythological drug. This is a BCL2 inhibitor. A what? BCL2 is a complex that cancer cells use to stay alive. You put this drug in there, stop that happening, all of a sudden they're vulnerable to chemotherapy. So it's an adjunctive form of therapy. So those are two things that we can see on the horizon because of what we know. So I can't tell you all the exciting things that are going to come in the future, but what I can guarantee you is that the future looks like this. What has happened in the last 10 years is amazing. What has happened in the last 50 years is amazing. What will happen in the next 10 years will blow our socks off. And this is why I'm not too scared when Pelham talks the way that he does. So, what we're going to do now is we're very, very fortunate to have Peter Campbell here from the Sanger Institute. Now, in our world, you say Sanger Institute and people go, and I had to say that because he's too modest, he wouldn't say that. And the Sanger Institute is a great example about how this country leads research worldwide. and how we punch above our weight. So it'll be great to hear from Peter later, but before we hear from Peter, I'm going to ask Matt Kaiser, who's our head of research, to come up and set the scene. So Matt's a recent recruit to the department. It's to the charity, to our group within the charity, and you cannot understand the excitement that I have to have just outside my office another geek who's really excited about science. So here is that geek.